In exercise 802, the good thing is the trigonometry stays the same. We'll still be working in a right angle triangle. We'll be using the Rech sine, cos and tan ratios to establish an equation, and we will solve the equation. So all of that stays the same, nothing new there. They will be, the questions will be worded questions. Again, we know when we've got a worded question that we should draw a diagram to identify a right angle triangle. So that's not new either. However, the words of the question are going to be different. The words in the question is going to include this concept of a bearing. So a bearing, you may or may not be aware, is the way of locating a position with respect to a given position. So the given position is always identified at the middle of our compass points. So we're going to be drawing compass points. Anytime you see a question with bearings in it, you could automatically draw your north, south, east and west, knowing that the bearing is given from the middle. So what is this bearing number? It is a 3-digit number, and it measures the angle between due north, which is here. It's an angle. So we know with an angle we've got to have two rays and the particular location. So it might be off over here. We might have somewhere over here that we want to talk about, this location. Or, let's get rid of that. It might be between this place and somewhere over here. So we would have an angle going around like that. So it is always the angle between due north in a clockwise direction. The hands of the clock go this way. And it shows us the direction. So we go from here over to here, and we would be on a bearing that is the measure of the angle that would be this size. Now, let's get a bit of an understanding of the size of the angles that these bearings could be. So we know that from here and due north, if we went out here, we went along here to due, that's called due east. The angle that is created would be that angle, which is 90 degrees. That's in the clockwise direction. If we went from here straight down due south, now we've got to think about the angle from due north. From due north, which is up there, let me just erase this. So we've identified that one. But from due north, coming down here south, it's this angle, and hopefully we all know that an angle that size would be 180. We said a bearing was a 3-digit number. That's only a 2-digit number. You will probably see a 0 between at the beginning. If then, on the other hand, we were going from here out west, due west. So the angle is always given from due north in a clockwise direction right around. So we've got 3 lots of 90, which would be a bearing of 270. And then finally, if we were going due north, we can give it 2 names. We can call it 360 degrees or 0. I suppose 0, 0, 3 degrees. So anything in between then becomes numbers in between those values. So if we went out here exactly halfway, so the angle between due north, so up there and out to here, if that was 45 degrees, the bearing would be 045. And in fact, when it's called northeast, it's understood to be exactly halfway between north and east. Down here, exactly halfway would be southeast. Again, this angle in here, just between there and there, is 45. But remember, it's the angle from due north. So it's all the way from up there to down here. So the actual bearing is 90 plus 45. So it's 135 as the bearing. 90 plus 45, you can get a calculator and check that. A bearing of 200 would be sitting approximately here, because from due north there's 180, 190, 200. We're going in a clockwise direction. A bearing of, say, 300 would be up here, getting very close to almost completing the 360 degrees. So that hopefully will give you an understanding of bearings. And it's a good idea if you can learn that first line, that a bearing is the measure of an angle between due north and a particular location in a clockwise direction. And it is a 3-digit figure. Now, at times, these parallel line properties, in particular the alternate angles, which is that one and that one, would be called alternate. And they're equal, or angles in that position and that position would be equal. We learnt that back in stage 5 with your parallel line properties. That becomes an important property to recall when we've got a situation that has two bearings. So we might be initially talking about a bearing from this location down to here. So this is one bearing, and we're going down to this spot here. Let's say we start at A and we're going to go to B. If then at B we talk about the bearing from B, we've got a new set of north, south, east and west. And what we know is that this line and this line are parallel. So we've got two parallel lines cut here. In fact, that angle in there and that angle in there would be these two. And what do we know about those? We know they're equal. Now, that's getting far more complicated. It will take some slow processing, step by step, to get those concepts. And we shouldn't come across that until we've established some good understanding of some simple bearing questions. Just remember that northeast, southeast, southwest and northwest all make angles of 45 degrees. And to illustrate that, you can see I've done that there. Now, don't be confused. These 45 degrees that I've put in, say, here and here, they don't tell me the bearing, they just tell me the size of the angle. The only one that tells me the bearing is that very first one. In fact, if we were going from here to here, the bearing would be 90 degrees. But we're going to be working in a right angle triangle, and sometimes these angles, being able to identify that as 45 or that as 45, will help in our right angle triangle. This is another example. If you know the angle in there is 33 degrees, that's great, and it might be relevant for completing a right angle triangle there. We've created a nice little right angle triangle. The angle inside the triangle is 33. However, the true bearing is not 33. What's our definition? Definition is a true bearing is the size of the angle from due north, so up here, in a clockwise direction around to A. Now, we can see that that is bigger than 180 degrees. We know it's less or somewhere between 180 and 270. The true bearing. To get the actual bearing, we can use the fact that to come right around would be 270. We want to come back 33. 270 take off 33 is 237. And that would be how you would answer that particular question. And you'll get to practice that again. Now, this next example is not too bad because the right angle triangle is actually given. So if we take a quick moment to understand where the triangle actually came from. It's Joel walks north and we're giving the bearing from here. So he walks north for 3.2 kilometres, and then when he's up here 3.2 kilometres away, he walks west for 4.4 kilometres. What is his true bearing from his starting point? So the true bearing is an angle from there right around to here, right around to there. We know that's some number bigger than 270. That is going to be the true bearing. However, that is never going to be part of a triangle because our angles cannot add to anything more than 180. So what we do is we work within a right angle triangle to find this angle in here, for example. So if we found that angle, we know that if we take that away from the 360, it will give us this true bearing. How much do we need to take off a complete 360 to get back to this number, something bigger than 270 degrees? Now, I'm not sure, you can see that I've redrawn that little right angle triangle. We're actually going to be finding this angle inside here. I'm not really sure why they've got an X on there. I'm finding that quite confusing. We can think about this as if we find that angle in there, we'll subtract that from 360 and that will give us the bearing. Now, with respect to, we're finding an angle. So with respect to the angle, we know that this is adjacent, and this is opposite. So we would have tan of theta. And tan theta is our 4.4, our opposite over our adjacent, subbing in, getting the angle, take tan inverse. And from the calculator, you can see that's 53.97. And they're degrees. Now, once we've got the angle inside there, then we know the actual bearing has to be the angle. Please make sure you've learnt this definition off by heart. You're making the questions very difficult for yourself to follow if you don't understand the definition of a bearing. Bearing is the angle between due north and a location in a clockwise direction. So if we're going through that many degrees, we've gone past 270. So we've got to get an angle size bigger than 270, and in this case, once we've found how much short we are of 360, which was the angle inside there, then we can subtract it from 360. I'll stop the video there and do the next example in another video.